Okay, today we are going to talk about the transformation of sine curves. Now, these transformations, they also apply to cosine and tan functions, but we are going to consider only sine here. So, the first thing you have to remember is that not all sine curves, they can be modeled like y equals sine x. Give you one example. For instance, we have a sine function like negative 5 sine 2x plus 90 degrees minus 18. This is a new form of sine function that you haven't seen, and you can easily see that it can't be represented by something like plain y equals sine x. From now on, remember, like quadratics, that y equal x squared used to be the base function, which had a graph U-shaped opening upward. We are going to have another base function called y equals sine x. So again, as usual, you have to memorize how the curve looks like, which is not hard. Now, how the function y equals sine x looks like, as I showed you yesterday, and we did a lot of graphings, y equals sine x looks like a periodic function, which is shown here in red, and on the right you have the table of values. Okay? Now, as I mentioned before, the table of values for sine functions, you don't need that many points here. The only points which are important to you are x, which are 0, 90, 180, 270, and 360. These are all degrees, remember. Okay? Now, 0 degree represented here, pi over 2, as I mentioned before, pi over 2 is the radian representation of 90 degrees. So this is really 90 degrees. Pi is the radian representation of 180 degrees. 3 pi over 2, which is this point, is 270 degrees. And 2 pi is 360 degrees. So the only points that you have to consider when you are doing, these sine functions are all these 5 points. These are the major points that you have to do the plotting. Now, if you want a better graph, go ahead and use in between values. For instance, here you have 30 degrees, 60 degrees, 120, 150, and so forth. So you do not necessarily need to have that many number of points to plot a sine function. Okay, in general, we can have a function of the form y equal a sine open bracket x minus c plus d. As I mentioned before, there is another parameter which is before x, which is really b, which we are not going to talk about this in this course. So the only ones you are concerned with are a, c, and d. And I showed you at the beginning of the lesson on Desmos that what will happen if you change any one of these parameters. So I'm just going to go through briefly and tell you what will happen if any one of these parameters change sign or change value. The first thing you have to remember that all these transformations, they are in order, meaning the reflections, they have to be done first. So the first the first transformation you always do is reflections. The second ones are stretch or compressions. And the third ones are the translations. Now, the translations, as you know, meaning moving right, left, up, down. So these are the lowest priority. The highest one are reflection and then stretch or compress along X or Y. But you are lucky we are not going to cover anything about compression or stretch along the x-axis. The only one that you are considered is along the y-axis. So the first one is A, which is the number which is multiplied by sine, this one. If A is negative, then what you are doing, you are flipping the graph of the base function, which is y equals sine x, about the x-axis. Okay? So remember, if A is negative, you're going to flip about x-axis. That's the first transformation, which is exactly the same as quadratics. The second transformation is when you take the absolute value of A. This is very important. You take the absolute value. Remember, the absolute value of a negative number is always positive. Of a positive number is always positive. So the absolute value as -5 is equal to 5. Absolute value of 3 is 3. So this means the absolute value is going to discard the sign here. Now, if you take the absolute value of A and it's greater than 1, then this is a stretch of the parent function or the base function y equals sine x. You stretch it along y-axis. This means that you take the graph and you pull it up and down along the y-axis. This is what stretch means. Or another way of looking at it, you're going to compress it along the x-axis. Because when you compress the sine curve along the x, you are going to stretch it along the y. That's another way of saying it. So this is when the absolute value is greater than 1. Meaning that A, absolute value of A, let's say A is -5, the absolute value of -5 is 5. So this means stretch along the y-axis. The next one is when the absolute value is between 1 and 0. Meaning you have A equal to -0.5. Remember, the absolute value of -0.5 is 0.5. Or you have, let's say, 0.13, which is going to be 0.13. Since the absolute value is between 1 and 0, we say that you are compressing along the y-axis. Now, when you compress about the y-axis, is the same as stretching along the x-axis, or vice versa. Okay, the next transformation is with regard to C. If in your transformed function C is positive, then it means that you are moving right C units. Now, remember that in the general formula that we had before, I will go back to the formula, C is a negative behind C. So whenever you see the transform function, look at the number inside the bracket, flip the sign, make it the opposite sign, and then compare it. If it's a positive number, then it means that you are going to the right. If it's negative, then you are going to the left. So if C is positive, then you are moving right C units. Give you one example. For instance, if I have y is equal to sine x minus 10 degrees. Because remember, the general formula is x minus c. So this means c is 10 here, which is positive 10. So this means that I'm going to move to the right 10 degrees, my y equals sine x graph. If I have a case, something like sine x plus pi over 2, I compare it with sine of x minus c. I can see that here they are different signs, so c is negative pi over 2. This means that I'm going to go to the left pi over 2. But pi over 2 in degrees is equal to 90 degrees. So this means that the y equals sine x is going to move to the left 90 degrees, which is the next transformation. If c is less than 0, then the graph of y equals sine x is moved left c units. Now, we covered the transformation dealing with A, C, and the last one is D, which is simple. You remember from quadratic functions. D is the translation or vertical translation along the y-axis. If D is greater than 0, then we are going to move up D units. This is a typing mistake. This is really D. And if D is less than 0, then the graph of y equals sine x is moved down D units. So it's very important. If D is positive, go up. If D is negative, go down. Now, when you look at the transform function, A has a special name in transformation of sine curves. A is called the amplitude. And remember yesterday we talked about the amplitude. We said the amplitude is the average, not the average, but maximum minus minimum divided by 2. This A here is really the amplitude of the transformed sine function. So you have to know the coefficient of sine is the amplitude of the transformed function. C, which is here, this parameter, has a special name called phase shift, which what you know is the horizontal translation. In case of quadratics, you used to say moving right or left, okay, 10 units. But now in sine situations, we don't call, translation right or left. We say the phase shift. The phase shift, for instance, is 10 degrees to the right. Okay? So remember the phase shift. And D, as usual, is the vertical translation going up or down. So these are the definition of A, C, and D. When you are trying to plot a transformed sine function, you can use table of values as before. I mean, everything stays the same. But there is another technique which is much, much easier, and this is what we call the mapping rule, which shows you the relation between the coordinate x and y of the parent function, which is y equals sine x, and the transformed function, okay, which is y equal a sine x minus c plus d, okay? Now, if we have the mapping rule in front of us, then plotting the points is very easy. You don't need to evaluate anything. Everything is done automatically for you. Now, the question is that what is the mapping rule for the transform function? So copy this mapping rule, which is in yellow, and I'm going to explain to you exactly what this one stands for. So if you have a transform function y equal a sine x minus c plus d, the one that we started the lesson with, the mapping rule is the following. X comma y goes to or transform to, so this is the transformation. How it's transformed is very simple. X is going to be added, the old coordinate x, you're just going to add c value to it. So you're going to have x plus c. The y coordinate is going to change to ay plus d. How did you come up with ay plus d? A is the number that multiplies by sine x, and then you add the d to it. This means that, give you one example. For instance, if I have, or I have an example which is right here. For instance, if I have a transform function which is shown here, y is equal to -3 sine x plus 30 degrees minus 10. Okay? So this is my transform function. I want to know point, what is the mapping rule for this function? The mapping rule is, as I said before in this formula, x comma y is going to transform to x plus c. If you look at this, you can see c is -30 because you just flip the sign. So it's going to be -30. So you say that x plus c becomes x minus c, which is x minus 30, comma, and y is ay plus 10. Your a value is -3, so it's going to be -3y. And then your d value is -10, so it becomes -3y minus 10. This is going to be your mapping rule. This means that if I have any point on my base function, I can find the transform point when I graph it using this mapping rule. Okay? Now, before I show you the answer, we know that the base function is y equals sine x. Okay? We know that. The base function for the sine transformation is always y equals sine x. Tell me, if x is 0, what is y value using this equation?
0.
Y equals sine 0, which is going to be 0. Okay? Now, if I ask you, what is the transformed notation of this point? Meaning, if this point is transformed, what is the new coordinate? Very simple. I use the mapping rule here. What is x value here? Here in this formula, I have to change x to the previous x. What was the x before? What was x before in the base function? 0. So I say 0 minus 30. What is 0 minus 30? Minus 30. Now, what is the y value in the base function? 0. So I put it back in this equation. What is -3 times 0? 0. What is 0 minus 10? So you can see 0.00, when it's transformed, it's going to become -30 degrees, comma, -10. Okay, so if I want to show you, step by step, again, the same example, 0, 0 is going to be transformed to -30 and -10. Okay? So just to make sure you understand it, let's say I say x is 90 degrees. Tell me what is y and what is the transformed point. So the base function, again, is y equal to sine x. If x is 90 degrees, I'm going to use the calculator. Sine of 90 is 1. Now I have the point 90 degrees and 1 on the base function, base graph, and I want to find the corresponding point on the transformed graph, which is this guy. But to find that one, I'm going to use the mapping rule. Since x is 90, I'm going to plug 90 here. So I get 90 minus 30 is for my x. Remember, these are degrees. And y is 1. So I'm going to say -3 times 1 minus 10. This one is the same as 90 minus 30 is 60. And -3 times 1 is -3 minus 1 is -13. Okay? So everybody understood the mapping rule, how you use the mapping rule. Now the question is that how do I use this one to really plot a graph and see how simple this becomes? So let's do one other example. So let's say that I give you y equals sine x, and I ask you to plot the graph of y equals sine x. As I said before, I am concerned with 5 major points: 0, 90, 180, 270, and 360. And hopefully by now you know the numbers. I mean, what is sine of 90? What is sine of 180? Otherwise, use your calculator. So I'm going to have the table of values, x, y, and I'm going to say when x is 0, y is 0. When x is 90, y is 1. When x is 180, y is 0. When x is 270, y is negative 1. When x is 360, y is 0. Then what I'm going to do is that, let's say the transform function, let's assume I have a transform function which is y equal to, let's say, sine x minus, let's say, 30 or minus 60 plus 1. And I'm supposed to plot the transform function too. Now, as I said, you can use your own table of values and then use, your calculator, or you can use the mapping rule. Now, the mapping rule for this function, this transform function, is again x comma y. Now, what do you think it is the x coordinate of the transform function now? What is c here? 60, because you're going to flip the sign. Negative 60 becomes positive 60. So you say x plus 60, comma. Now, what is a here? 1, not 0, 1. And what is d here? So what is the formula for y now? A, y plus d. So it's going to be 1, y plus 1, which is y plus 1.
Well, wasn't it 13 or something like that?
William, it all depends on the equation that you're given.
Yeah, this is the equation now. Okay? So you say that the mapping rule is x plus 60 and y plus 1. How it's going to help me is very simple. Take this and then come up with a new table of values. For every x, add 60 to it. So what is 0 plus 60? 60. What is 90 plus 60? What is 180 plus 60? What is 180 plus 60? 240. What is 270 plus 60? What is 360 plus 60? Now, you do exactly the same thing for y, but this time you are going to have the equation y plus 1. So what is 0 plus 1? What is 1 plus 1? What is 0 plus 1? What is negative 1 plus 1? What is 0 plus 1? 1. Okay? And that's all you need. Now, you want to plot this one? Roughly, this is how we plot it. We know that for base function, which is sine x, I'm going to use 90, 180, 270, and 360. Now, when x is 0, y is 0, I'm using the base function. When x is 90, y is 1, let's say is here. When x is 180, y is 0, which is here. When x is 270, y is negative 1, which is, let's say, here. When x is 360, y is 0. You get here. So you get a curve like this one. This is your base function, y equals sine x. And I said you should memorize it, how it looks. Okay? Now, let's see how I can do this one now. It says when x is 60 now. This is 90. So this means I'm going to go, say, 30 degrees to the left. So this is, I call 60. Okay? When x is 150, so again, I go to the left, which is 150 here. So I write 150 here. 240, 270, which is somewhere around here. So this is 240. Then 330, again, I go 30 units to the left. This one, we don't need it. I mean, we just have to go 30 to the left. Let me see why we have 2, 4, 5. No, 420. Yeah, this is correct. Sorry. 330 is going to be this point, and 420 is going to be somewhere around here. Now, when x is 60, y is 1. When x is 60 here, y is 1, which is here, the same place. Remember, this is 1. When x is 150, y is 2. Now, if this is 2, y is going to be somewhere around here. When x is 240, which is here, y is 1. So it's going to be somewhere around here. Okay? When x is 330, y is 0. When x is 330, y is 0, which is here. So I have this point, this point, this point, this point. And when x is 420, which is here, y is 1. So my transform function looks like this. Okay, the first question is, sketch the graph of y equals sine x plus 1 for one cycle. Remember, I don't want 2, 3. I want only one cycle of y equals sine x plus 1. And I'm going to specify the limit for x. X between 360 and 0. And then specify the period, amplitude, phase shift, domain, range, equation of horizontal axis of cycle. This line is the line that goes right in between the amplitude. So this is the one that is going to half the amplitude. I'm going to show you. It's nothing special about it. We used to have axis of symmetry, if you remember. This is the name for axis of symmetry for a sine curve. This means that your sine curve is going to be half, right in the middle. So go ahead. Plot y equals sine x plus 1. Okay, to plot something like y equals sine x plus 1, okay, what I'm going to do is that I'm going to find the table of value for the parent function, which I already know by heart, that is going to be xy. When x is 0, 90, 180, 270, and 360. I know this is 0, this is 1, 0, negative 1, 0. Now, the mapping rule for this function is what? Xy becomes, okay, remember that c is 0 here. There is no c, okay? So your x is going to be x plus c, which is x plus 0, which is going to be x. Meaning that x is not going to change. But the y value is going to be ay plus d. A is 1. There is no coefficient here. So it's going to be 1y plus d. What is d here? 1. So your mapping function is going to be y plus 1. So x comma y plus 1. This means that this table of value is going to be transformed by changing only the y coordinate. And how do you change it? You just add 1 to it. So the new table of value for this function becomes x, y. Again, because of the mapping rule, x is not changed. So it stays at 0, 90, 180, 270, and 360. But the y values are going to be incremented by 1. So it's going to be 1, 2, 1, 0, and 1. Now, to plot this one is a matter of drawing your x and y coordinates. When x is, this is 90, let's say, this is 180, this is 270, and this is 360. When x is 0, y is 1. So when x is 0, y is 1, which is here. When x is 90, which is here, y is 2, which is going to be here. Let's say this is 2, this is 1. When x is 180, which is here, y is 1. When x is 270, y is 0, which is here. And when x is 360, y is 1, which is going to be here. And you can see how the graph looks like. Remember, this is 0, 90, 180, 270, and 360. Now, knowing this, the following questions, they have to be answered. What is the period? The period, as you can see, one cycle starts at 0 and ends up at 360. So the period, you're going to say period is 360 degrees, which is 2 pi. For the amplitude, remember, the maximum is here, the minimum is here. So you say the amplitude is maximum 2 minus minimum, which is 0, divided by 2, which is going to be 1. So the amplitude is 1. The phase shift. The phase shift is the C value, and you can see that the C is 0. So you say the phase shift, PS, is going to be 0. And the last one is the equation of the horizontal axis of cycle. The horizontal axis of cycle is the line which goes right in between these two, the maximum and minimum. Now, what is the coordinate of this point?
X equals 2 and
Y equal to 1. Because right here, y is 1. So you say the equation of axis of cycle is y equal to 1. Exactly the same thing that you learned in quadratics, axis of symmetry. Okay? Although this is not really symmetric about the line, but this is the one which goes right in the middle of the sine curve.